In the previous video, we have learned about the individual transformation processes, but more often than not, questions will usually involve more than one consecutive transformations to be performed on the function. These are called composite transformations. In composite functions, the order in which we carry out the individual transformations is very important. Not following the correct order will lead to erroneous results, which I will illustrate using the following example, where we have to perform two consecutive transformations to transform y equals to fx into y equals to f of 2x plus 3. If we perform the scaling transformation first, meaning we take care of the 2x before the plus 3, we will have the following transformations: y equals to fx becoming y equals to f 2x, and thereafter we are going to change the x into x plus 3. However, note that the x plus 3 is only going to replace the x alone instead of the entire function. Therefore, what we see is that this is going to become y equals to f of 2x plus 6, which is not the correct one that we are intended for. However, if we perform translation first, we will have fx becoming f of x plus 3, y equals to fx becomes y equals to f x plus 3, and thereafter, if we perform the scaling of factor half, we will end up with y equals to f of 2x plus 3. So I'm just replacing the x by 2x, not the entire expression multiplied by 2. Take note of that. And this is the same as y equals to f 2x plus 3, which is in the correct order that is required. Thus, through this simple example, we can see the importance of following the correct order when performing transformations consecutively. It may be confusing to memorize the many rules required to perform composite transformations in the correct order. Thus, I have simplified the process into 3 simple guidelines. Number 1, it does not matter whether we perform all the operations on x first or on fx first. For example, if I have the equation of y equals to 2f 3x plus 4 plus 5, it does not matter whether I perform these two operations on the x first or whether I perform the operations on the 2 and 5 first. However, for the sake of uniformity, I will always choose to perform all the operations on x first. Number 2, for operations on x, the golden rule is to start from the term furthest away from x and slowly move in towards x. In other words, we work outside in. For example, if I have the function of y equals to f 3x plus 4, we will perform the translation first since the 4 is further away from x. Then we will perform the scaling because the next nearest to x will be 3. If we look at a more complicated example, now if I have y equals to f negative mod x plus 4, we can use the same rule to start from 4, followed by the negative, and finally the modulus. Number 3, for operations on fx, we follow the opposite rule. We start from the term nearest to fx first and progressively move away from fx. For example, if we have the function y equals to 2fx plus 3, we will start from the 2 first and perform a scaling with a factor of 2, followed by 3, which is a translation 3 units in the positive y direction. Now, if I have a more complicated example, let's say y equals to negative mod 2fx plus 3 plus 4, the correct order that we should perform the transformations will be number 1, the 2, followed by the 3, followed by the modulus, then the negative sign, and finally the 4. Now let's put to practice the rules that we have just learned using the following examples. In example 1, we need to write down the correct order of transformations to transform the graph of y equals to fx into y equals to minus 2f of 3x plus 4 minus 5. Following our earlier rules, we will first perform all the x transformations. And for the x transformations, we will do it outside in. And so the first term that we will work on is the 4, which is a translation in the negative x direction by 4 units. This is followed by the 3, which is scaling parallel to the x-axis by a factor of 1/3. With all the x operations done, we will now look at the operations on fx, which we will start inside out from fx. So the first one that we will look at is the 2, which is a scaling parallel to the y-axis by a factor of 2. Next will be the negative, which is a reflection about the x-axis. And finally, the 5, which is a translation in the negative y direction by 5 units. In example 2, we have some additional modular signs, but the rules remain the same. Let's check it out. If we perform the x operations first, we will start from the 4, followed by the 3, followed by the smaller modulus within the bracket. Next, for the operations on fx, we will start from minus 5, followed by the modulus, followed by the 2, and finally the minus sign. Example 3 is slightly different. We are now given an unknown expression of y equals to fx, and we know that fx undergoes 2 consecutive transformations a and b to arrive at the final expression as given over here, which I shall call it gx. So now, given that I know the expression for gx, can we work backwards to find out what is the expression for fx? That is the critical point of this example here. So if we look at the forward order, starting from y equals to fx, what happens is I'm going to undergo a transformation of a first, which is a translation of 2 units in the x direction. That means I will end up with y equals to f of x minus 2. And thereafter, I'm going to perform a second transformation b, which is scaling parallel to the x-axis by a factor of 3. That means I'm going to change the x into 1/3 x, which gives me y equals to f x over 3 minus 2. And this is equals to gx. Now, if I think of it in the other order, if I were to start from y equals to gx, I will have to first undergo the reverse process of transformation b. So since transformation b is a scaling parallel to the x-axis by a factor of 3, b inverse becomes a scaling parallel to the x-axis by a factor of 1/3. So I will end up with y equals to g3x. And from g3x, I will need to perform the reverse of transformation a, which is a inverse. And this gives me y equals to g of 3 times of x plus 2, which becomes g 3x plus 6. And therefore, I know that the expression for fx is equals to the expression of g of 3x plus 6. And since gx is equals to 4x plus 3 plus 1 over 2x minus 1 squared, fx will be equals to 3x plus 6 plus 3 plus 1 over 2 times of 3x plus 6 minus 1 squared. And if we simplify this, we will end up with 12x plus 27 plus 1 over 6x plus 11 squared.